Okay, so now that we've looked at dividing by monomials, we're going to look at dividing by binomials and trinomials, but specifically binomials. The trinomial idea will continue in the same sort of pattern, but let's look at binomials for a moment. Before I really can get into the binomials, I want to give you a little refresher on dividing numbers, long division of numbers. So let me give you a quick example, something like 576 divided by 12, okay? If I were to divide this using long division, you would take the 12 on the outside and the 576 on the inside. Now, yes, I am using this as a precursor to division of polynomials because we're going to long divide polynomials in just a moment, and it's quite a process. So we'll do it with a numerical example, and then I'll show you how the polynomials work out. So first, remember when you divide with numbers, you take the divisor, divide it into the dividend using the largest values, largest place values. So I would start by using 12 into the 57 and kind of ignore the 6 for a moment. Actually, if I didn't know, like right now, if I wasn't sure how many times 12 went into 57, I might estimate it by just taking the 1 into the 5, right? The biggest place value into the biggest place value. And 1 goes into 5 times. But I know 5 times 12 is going to be too much, right? 12 doesn't go into 57 5 times because that would be 60. 5 times 12 is 60. So it's going to be 1 less. The 1 into the 5 gets us a rough idea, but it's not always exact. And so here, 12 goes into 57 4 times. It's 1 less than what I was thinking. 4 times 12 is 48. So remember, we multiply down to find our remainder. 57 minus 48 is 9. We bring down the 6. And now we can divide up the 96. 12 goes into 96. That works out evenly at 8. 8 times 12 is 96. And our remainder is 0. It's always nice when the remainder is 0. Okay? That means that 12 is actually a factor of 576. Now, we'll do an example here, kind of work through a long division with polynomials and show you how that's done. So here, let's take the example, let's do 3x squared plus 22x plus 24 and divide that by x plus 6. Okay, so again here, I'm dividing a trinomial by a binomial. You could think of this in fraction form as well. It'd be the trinomial here over x plus 6. I'm not going to rewrite it all because, it's kind of redundant, but it's the same idea. If you have the fraction form or the division form, they mean the same thing. So what I'm going to do is I'm going to take the divisor, which is always the second one, or the denominator, whichever one, whichever form it's in, and I'm going to put that on the outside of the division, the long division symbol. So I got x plus 6, then my long division, and it's long this time, right? It's definitely long because my dividend, or numerator, has to go inside. And so that's going to be 3x squared plus 22x plus 24. Okay? So now, just like we did with the numerical example, we're going to take the divisor and divide it into the largest place values here, right? So 12 into 5 or 12 into 57 until it works out. And what I said, we try the 1 into the 5 first, the largest place values into the largest place value, and see if that works. Well, we'll do the same thing here. With a polynomial, though, the largest place values are the largest degree terms. So I would start by trying to divide x into 3x squared. Same way I would divide 1 into 5 here. Well, this time x does go into 3x squared nicely. And so if you consider what 3x squared over x is, the answer to that is 3x, right? The x is reduced. Oops, let's write it horizontally. So that 3x, the result, is what goes up on top. Remember here when I divided the 12 into the 57, we got 4. The 4 is what went on top. Well, here the 3x is what's going to go on top. And always, always, always line up your degrees. So if I have an x in this, a 3x, it must go above the x term in the dividend, okay? It's going to be the nicest way to keep track of everything. So the 3x goes above the 22x. Then we multiply down. Just like here, we multiplied 4 times 12 to get 48. We're going to do the same thing here. 3x times the x plus 6. Okay, so when we do that, 3x times x gives us 3x squared. And then 3x times 6 gives us 18x. Now again, with the numerical example, the next step is to subtract so that we can find the remainder. Okay, well, the remainder in this step. And so to do that, I'm going to subtract here as well. Now with subtraction, the subtraction has to distribute to both terms. It applies to both terms because I want to subtract and find the remainder, what's left. So I'm going to subtract both the 3x squared and the 18x. Some people have a phrase for this. They say, change the sign, draw the line. Okay, so I always change the signs, draw the line. If you're subtracting, you remember you always change the sign. So here, this one, the 3 becomes negative, the 18 becomes negative. If this were a subtraction, I would make it a plus. Okay, so you always change the sign when you distribute the minus. After that, then we can do the subtraction. Well, the first term should always drop out. If it doesn't drop out, you did something wrong. The second term, 22 minus 18, here that gives us a 4x. Okay, so you always just calculate that one. And then just like we do over here on the numerical example, you bring down the 6. Here we're going to bring down the 24. Okay, then repeat the process. Here we divided 12 into 96. Here we're going to divide the x plus 6 into the 4x plus 24. Again, taking the first term into the first term. So x goes into 4x. Now that'd be 4 times, right? So you take the 4x divided by x, you get 4. That 4 is a constant, no variable on it. So it needs to go up above the constant. So we're going to go plus 4. 4 times x is 4x. 4 times 6 is 24. And again, change the sign, draw the line. We're doing a subtraction, just like we did here, but you got to subtract everything, right? So I have to subtract the 4x, I have to subtract the 24, and then draw the line. Change the sign, draw the line. The 4x's drop out. Those, again, should always drop out. The other term here nicely subtracts out to 0. Okay, that won't always happen, but in this case it does. If our final remainder is 0, that means the original x plus 6 was a factor of the original dividend, okay? So that means the 3x squared plus 22x plus 24 is equal, if you factored it, is equal to something times x plus 6, okay? So that worked, and in fact, that one thing, the thing that we're multiplying the x plus 6 by is 3x plus 4, okay? So the answer here is 3x plus 4. That's the final answer because that is the quotient when you divide our trinomial by x plus 6. Okay? We'll do a couple more examples. Hopefully this process will start to make more sense. The next example, I want to show you what happens when we have a remainder. And again, we'll initiate this by using a numerical example with a remainder. Okay, so let's try a numerical example. Let's do 6,581 divided by 22. Okay, so again, the 22 goes on the outside. The 6,581 goes on the inside. And again, when I divide, I want to start by taking the largest place value divided into the largest place value. So 2 goes into 6 3 times, right? Well, 22, so does that mean 22 goes into 65 3 times? Unfortunately, no, we're going to be too high. That would be 66. So I'm going to go 2 times instead. Okay. 2 times 22 is 44. When I do that subtraction, that's going to give me a 21, right? Yeah, 21. Then I bring down the 8. And of course, 22 goes into 21. It doesn't go into 21, unfortunately, 0 times. But it's pretty close. So 2 goes into 21 10 times. We're going to have to back off of that 1 because it would be too many. So we'll go 9 times, see if that works. 9 times 22. Well, 9 times 2 is 18. 9 times 2 is 18 plus 1 is 19. And then I subtract 0. That'd be a 2. 21 minus 19 is 2. And then I want to bring down the 1. So I got to bring down another number. 22 goes into 201. Oh, let's see. Well, we already know that 9 times 22 is 198. That's pretty close to 201, so it's going to be another 9, right? 9 times 22 is 198, and our remainder is 3. Now, if you'll recall, when we do long division and the remainder is not 0, we create something called a mixed number. Okay, and so the actual answer here is 299 and 3/22. Right, so remember, final answer 299 and 3/22, 3/22. So it's slightly more than 299, but it's not 300. Okay, and so that's our mixed number form. Now, also remember that a mixed number is simply a whole number plus a fraction, right? And that fraction has the remainder on top and the divisor on the bottom. That's going to be very important to note. Remainder on top, divisor on the bottom. The quotient then is out front. Okay, so we're going to use that same idea to divide polynomials. All right, let's look at an example. Let's do 8x squared plus 6x minus 25 divided by 4x plus 9. Okay, so again, the second one listed goes on the outside. That's your divisor. And then the first one listed, or your numerator, goes on the inside, because that is your dividend. All right, and then we're going to divide in a similar way. We're going to take the first term into the first term. So 8x squared divided by 4x is going to be 2x. That 2x being an x term goes above the x term. So the 2x goes above the 6x. And then again, we multiply down. So 2x times 4x is 8x squared. 2x times 9 is 18x. Remember, we change the sign, draw the line. So change your signs, draw your line. Okay. Then the 8x squares drop out. Remember, that should always happen where the first term drops out. 6x minus 18x is minus 12x. Then we bring down the minus 25. Okay. Then we do our division again. We do first term divided into the first term. So negative 12x divided by 4x. Well, the x's drop out, negative 12 over 4 is negative 3. Because that's a constant, it must go above the constant term. And then we multiply down. So negative 3 times 4x is negative 12x. Negative 3 times 9 is negative 27. Again, change your signs, draw the line. This time, when I change the signs, I'm going to change them from negatives to positives, right? Subtracting negatives is the same as adding. So, I'm going to change those two signs, then draw my line, and then combine the terms. Well, negative 12 plus 12 is 0. That should add up to 0 every time. Negative 25 plus 27 is 2. My remainder is 2. I don't have anything else to bring down. And so now I have the situation where my remainder is not 0, so I don't have a perfect factor of the original dividend. Instead, I want to write my answer in sort of a mixed polynomial sort of idea. Here we had the mixed fraction idea with a number. We take the quotient, remember, and add to that the remainder over the divisor. Well, here we're going to do the same thing. We're going to take the quotient, 2x minus 3, and add to that the remainder over the original divisor. And so this is sort of combining the polynomial and rational expression idea. Okay, just like with numbers, you're combining whole numbers and fractions. Here we're combining polynomials and their fraction equivalent, okay, which are rational expressions. All right, so that's how we treat the division process when there's not a remainder of 0. Let's take a look at one more example before we end our discussion on division. Okay. So this last one, let's do 4x to the third minus 6x minus 11, and we'll divide that by 2x minus 4. Okay. So here, again, second one, or the denominator, comes out as your divisor, and that comes outside. Now, when we write out the dividend underneath, there's one thing I really want to point out, and that is, look at the powers on the x's here. It appears that we're missing one, right? I've got 3, 1, and 0. I'm missing the 2. We don't ever want to skip that. We want to include all powers of x, starting from the largest and going down. So I actually want to include the 0 there, okay? So when I write this down, I'm going to have 4x to the third plus 0x squared, right? That's the one we're skipping, or that's the one we don't want to skip, minus 6x minus 11. Right, so then I've got all of my powers included. Now that might seem a little strange, and of course it does. It's very easy to forget as well. But if you think about it in the example of a number, if I were to do a long division on something like, I don't know, 308 divided by 14, you wouldn't write it out as 14 into 38, right? That wouldn't make sense. You need the 0. The 0 is super important in the long division, right? Dividing 14 into 38 is way different than 14 into 308. And in a similar way, dividing 2x minus 4 into 4x cubed minus 6x minus 11 without the 0x squared is way different than doing it with, okay? And so we don't want to miss that. We don't want to skip over that 0. So we're going to have to include that. And that's also true for the dividend, or sorry, the divisor. So if the divisor is missing a term, or a power of x, you want to include it as a 0. It could be the case that you have like an x squared minus 9 out there. You'd want to include the 0x, so the x squared plus 0x minus 9. Okay, so you always want to make sure to fill in the missing powers with a 0. Now I can go through my process, and everything should line up just fine. So again, we're going to start with the biggest term into the biggest term. Take 4x cubed divided by 2x. That simplifies down to a 2x squared. Because it is an x squared term, it needs to go above the x squared, okay, which is why we need that 0 in there. So we get 2x squared. Then we multiply down. So 2x squared times 2x is 4x cubed. 2x squared times minus 4 is minus 8x squared. And just like we said before, change the signs, draw the line. So here, change my sign because I'm subtracting. Change this sign because I'm subtracting. And draw my line. I always change color because I can see it better that way, but you may not have that option. But just remember to change both signs and then draw your line. The 4x cubes drop out. We get an 8x squared when I combine those. Bring down the minus 6x. Okay. Now, I'm going to again divide big term into big term. So we get, what's that? 8x squared divided by 2x. That'll be 4x. Okay. Because it's an x term, it goes above the x term. Put the 4x up there. 4x, and we multiply down. 4x times 2x is 8x squared. Should always match up. 4x times negative 4 is a negative 16x. And again, change the sign, draw the line. Don't forget that step. Change both signs. Draw that line down. The 8x squares drop out. Negative 6 plus 16 is 10x. And then I bring down the minus 11. And again, divide big term into big term. So it'd be 10x into 2x. Now I always write these down off to the side just to keep track of what I'm doing. Yeah, it just helps me out. So then this 5 is constant. It must go above the constant term. And it's a positive, so I'll put plus in there. And then we distribute down again. So 5 times 2x is 10x. 5 times negative 4 is negative 20. Again, change the sign, draw the line. And the 10x's drop out. Negative 11 plus 20 is 9. Our remainder here is 9. There's nothing else to bring down. And so our final answer is going to be the quotient plus 9 over the divisor. Okay? So it's going to be that mixed polynomial rational expression stuff. So when I write this out, in fact, I may go right up here to the top. It's going to be 2x squared plus 4x plus 5 plus 9 over 2x minus 4. So again, we're adding a polynomial and a rational expression together, just like we would add a whole number and a fraction to get a mixed number. Okay. One thing I want to point out, if this remainder were a negative number, I would have to put a minus here on my fraction. Okay. Okay, I think that pretty much hits everything. There's a lot of little details in these. So definitely practice them, do all the examples in the homework. The more practice you get, the better, because yeah, these are one of the more complicated things that we're going to be doing, I think, because there's so many details, so many things to write out and keep track of. So be very careful with them and really pay attention. If you need extra examples, make sure to look in your textbook and your ebook, or check out the little help features on my math lab.